Welcome to Highline Excel class number 48. Hey, if you want to download this workbook and follow along, click on my YouTube channel, then click on my college website link, and you can download the workbook, Week 9, Chapter 2, Business 214. If you're in the class, just go to our class website. Hey, we got to talk about interest rates. We got 6 great tricks for interest rates. Our first one is calculated an adjusted annual rate when you have points on a loan. Now, when you go to calculate your PMT, as we saw in our last video, we are going to use this C11, whatever the full loan amount is, because we actually owe that amount. So we have to use that amount. However, when we calculate our adjusted annual rate, it looks like we had an annual rate of 5%. When we calculate our adjusted annual rate, we can't use this 200,000 because we didn't get to keep that 200,000. They took 2% of it up front. So when calculating the rate, you have to use 200,000 and subtract 2%, which what we'll do is we'll do 200,000 times 1 minus 0.02, which is 0.98. All right, we're going to use the rate function. We saw the PMT and future value, but this will be rate. Rate is like all the rest. NPER, payment, etc., have to be in the same time period. And we have months here. So our NPER will be total months, comma, our PMT will be this. And from our point of view, it's going to be negative because we're paying it out of our wallet each month, comma, and the present value. This is going to be positive because when we take out the loan, it's coming into our wallet. Even though we're going to immediately pay it out, it's still, our relationship with the bank or the creditor is we get money from them, and then we give it to whoever, the house or whoever we're buying this expensive car from. But here it is. We can't use the whole 200,000 because we're not getting use of it. They took 2%. So what we're going to do is we're going to take 200,000 times, in parentheses, 1 minus 0.02. That's an easy way to subtract 2%. So that is our present value, and it is positive, comma. Looks like we don't have a future value. There's no lump sum payment. We don't have to put a type because it's 0 by default, and we don't have to put a guess, although if it was having trouble iterating, we could do that. Close parentheses and enter. Now, that would be great if our annual rate is that. Look at this. As we've mentioned a few times, remember, NPER, PMT are all in month. Well, of course, the rate function spits out a monthly rate. So to get back to our annual rate, our APR, we have to say 12 here, times, and then enter. And that gives us our 5.31. Now, we could get rid of the formatting, applying general format, and see the full decimal there if we wanted. So that is adjusted annual rate. Let's look at our next trick. We're going to look at the effect function. We're also going to look at the math to calculate effective rate. Just over here, we are calculating adjusted annual rate, but that is an APR. That doesn't take into consideration compounding. Whoops. So we're going to see how to go from an APR, or nominal rate, so here's our APR, or nominal rate, and we need to figure out the effective annual rate, which will take into consideration compounding. Hey, here's our annual rate. Can we figure out the period rate? Sure we can. If it's whatever the APR, or nominal rate, divided by the number of compounding periods. We've done this a bunch so far in this class when using PMT and future value, etc. Enter. So there it is. There's our period rate. So per month, it's less than 1%. Now, how do you calculate the effective rate? I'm going to show you the math, and then I'm going to show you the built-in function. And for some situations, you have to use the math because the function has a slight drawback, which we'll see in a couple tricks ahead. All right, so the effective annual rate, we're going to say equals, open parentheses, 1 plus our period rate, close parentheses, and then we're going to have to raise it to this 12 right here, caret, and the 12. that says, hey, take 1 plus all of those and do compounding 12 times. Now, when I control enter, it's going to give us 1 plus the interest rate. So I'm going to hit F2, and then you actually have to subtract 1. That's the formula, and in some circumstances, you have to use that one when calculating an effective rate. Now, in our circumstance, since number of compounding periods per year is an integer, which most of the times it is, we don't have to know this math. We can just use the built-in effect. And effect says take the nominal rate. Oh, yeah, that's our APR divided by NPERY. I don't know why they changed the notation here, but that's like our NPER that we saw before. 12 periods per year, close parentheses, and then enter, and that calculates it. So effective rate, why in the world do we have to do that? Well, you know, a lot of banks quote the annual rate, and it's a little misleading. If there's more than one compounding period per year, which we have 12, then our effective annual rate is this. And what does it mean? It means if we only had one compounding period during the year, this is the rate we'd have to use. Let's see an example here. 100 bucks. And I'm going to call that my, if I come over here, I could say that's amount put in bank on day 1. Now that's scooting off the edge of it. That's OK. Now, what would I have to do to figure out how much it's worth at the end of the year? I'd have to use even my future value function equals FV. The rate is going to be our period rate, comma, the NPER. This is only 1 year, so I'm going to use this one. Our payment, we don't have a payment, but we do, comma, have a present value. And that is our $100 right here. Now, you got to think about this. When you're doing future value calculation, on the moment that you put this into the bank, since this is from our point of view, it comes out of our wallet. So we have to put a minus here. That way, that minus, that means we put it into the bank. When we withdraw it 1 year later, it's coming back into our wallet. Close parentheses, and we get a fence. Now, a different way, if you don't, the future value function is nice and easy to use. The math behind it would be equals 1 plus our annual, our period rate here, caret, and we'd caret this 12. And then this whole thing times our 100. Now, we can get away with this because exponents are done in the order of operations before multiplying and dividing. So then we hit enter, and we get the same number. Now, let's try this. Remember, we're trying to explain what in the world the effective annual rate is. Well, watch this. Once we have this, we say equals the 100 times that flat rate. That's as if we're taking this APR, 12 periods per year. We convert it to a new APR, which is just 1 period per year. So look at this. Enter. We forgot to do the 1 plus. So we need to take our $100. And right now, it's just giving us the interest. If I hit enter, you can see that that's just the interest. So the way you add interest and the principal together is, of course, in parentheses, 1 plus that rate. So when we use the distributive property, that $100 times that is 100. That $100 times that interest rate is the interest rate, and then it adds it together. So there we have it. That's what the effective annual rate is. And really, if you're looking at a loan or something, you do want to look at this because it gives you at least it says to you that it's truly the effective rate is higher than the APR. Let's go to our next trick, and where we'll use the effective interest rate and the nominal rate. This is called the nominal rate. Here's a great situation. We have a savings plan that compounds interest 365 times a year, but you put money in 12 times a year. Well, you can't just go and calculate your future value without doing a couple extra calculations, because interest is paid a different number of times a year than you're putting money in. So we're going to put 250 bucks in a year. for 25 years. But the account says 365, 8% APR. Now, the way you do this is kind of like a three-step process. You first solve for the new effective annual rate. Then from the effective annual rate, you figure out the annual percentage rate, and then you figure out the period rate. So you ready? We're going to use our effect. And we want to click our nominal rate. It's going to be 8% or 0.08 as a decimal, comma, the NPER. Oh, that's our 365. So we're going to go from the 8% now at APR and figure out what the effective rate is. Oh, and isn't that convenient? Because that is now the rate with one compounding period per year. Oh, but that's not going to do us much good because we eventually need an APR period rate to put into our PMT function. So we'll use the nominal function. So we went from this 365 with a different number of periods than our 12. We went from that to effective. Now we have to go back to APR or nominal. It's asking for the effective rate, so we take that, comma, and our NPER for us putting the money in each month is going to be 12. Close parentheses. And so now we have an APR. And from that, we can simply divide by 12. And that gives us our period rate, which we can use for our solving for our future value. Equals future value. Now our rate, after all those 1, 2, 3 steps, is going to be this, our period rate, comma, the NPER. That's going to be 25 years times our 12 periods per year for us putting it in, comma, the PMT. I've already put it as negative. From our point of view, it is negative, or it's coming out of our wallet. And we have an end and no present value amount, so we can leave those two arguments off. Anytime you see the square brackets, it means the function will work without those. Close parentheses and enter. So there it is. If we have a savings plan that compounds interest 365 times a year, but we put $250 in only 12 times a year, the future value would be $238,757.59. Now, another great trick, two more tricks. This is the money tree. The loaners, the people that come out and say, hey, you have a check coming to you in 25 days for $250. We'll give you $200 today for that $250 in 25 days. Well, of course, this is not a good deal, and you should never do this. The first thing we have to do is calculate the interest rate we're paying for our 25-day period. This is going to be a period rate. Now, earlier in this class, we learned how to calculate the change between any two items, begin and end. So the increase between these two will give us the interest rate. So equals the end amount divided by the begin amount. And then we have to subtract 1. This is the third or fourth time we've seen this in this class, but boy, is it good to know. And really, all we're doing is we're saying, hey, that 50 extra bucks, we have to compare it to the 200, and that tells us the rate. You can do this in your head. 50 divided by 200 is 1/4. So you're paying 25% interest rate for every 25 days? That's amazing. Now, the next step is we say, oh, well, if that's true, we're paying 25% for every 25 days. What's the APR, or annual rate? We have to click right here, and we're going to say equals the 365 days, which are in a year, divided by our period. Our period is 25 days. Notice days, days. Total days in the period, 365 days. Days for our loan, where we have a period rate, is 25. So when we hit enter, oh, we have that. There's 14.6 25-day periods in a 365-day year. Now, to calculate APR, no problem. This will seem less bad than when we actually do the the truth, which is what is the effective annual rate. Because the APR, because the period rate is so big here, APR is totally misleading. So you ready? We say equals whatever this rate is, because APR, in this class we've always gone from APR to period rate. So we take the APR and we divide by 12. Here we have to take the period rate and multiply it times the number of periods, which is right here. So in essence, if we were given this rate right here, 365%, to get to our period rate, we'd divide by 14.6. But we really did the reverse. We knew what our rate was for a particular period, 25 days. We had to find out how many of those periods are in 1 year. Then we simply multiplied this times that. 365% interest rate. Now, what is the effective interest rate? Well, here's the deal. The effective interest rate effect function, which we'll do here, it gives us a good approximation. But the effect function doesn't work on decimals. It truncates to the integer. So if we do effect down here equals effect, we take our nominal rate, or APR, divided by our 14. It doesn't tell us. If you go up into help, it says it. But it doesn't tell us right up front that it's going to change that to a 14. It still will shock us. And this still is a great estimation. So I'm going to hit Enter. Yeah, that's right. 2,462%. That is your effective annual rate. That is why these money trees loan people charge a lot. That would be understating it. Let's do the math. Equals, in parentheses, 1 plus, our period rate, close parentheses, caret, raised to our number of periods per year. And then, of course, we have to subtract 1. All right, so it's a little bit bigger. We could see 2,499, so it's like 2,500%. So that's what Money Tree and Loan, whatever the other ones are, Loan Today, whatever. Huge interest rate. We also see that APR doesn't really do it justice. We really need to go to the effective annual rate to see how much damage is being done. One last trick here. This is in the vein of that Money Tree loan. Here it is. How long to pay off your credit card if you pay only the minimum payment required. So you have a balance of 2,000. The annual interest rate is 18%, compounded 12 times a year. And there it is. On your credit card statement, it says 41 bucks. Well, we're going to use the MPER function to figure out how many periods. Right? So you ready? Equals NPER. And this will be great, just like the rate back here and just like payment. All of the time periods need to be the same. So what is rate? Rate, well, we didn't do our monthly rate, so we're going to have to do it right here in the formula. 18% divided by 12. Comma, and what's our payment? Oh, it's a minus. This is the 41, so I'm going to put a minus here. I didn't put the minus in the face of the spreadsheet, but there it is. It's coming out of our pocket and going to the bank, comma, our present value. Now, this is positive because this is the credit card company, in essence, giving you the money to buy all this stuff when you bought it. So there it is. And we don't have any amount left at the end, and this is the type 0. Now, take notice here. Rate and PMT are both in month periods. The time period is months. So when you hit Enter, the NPER function is going to spit out months. So to go to years, we say equals that total number of periods times the 12. And that's how many years. Oh, we did something wrong there. Divided by, sorry. Yeah, this is all of the periods, and we want to figure out years. So of course, since there's 12 months in a year, you have to divide. All right, so there it will take 7.36, 7 1/3 years to pay off the credit card if we make only the minimum payments each period. Very painful stuff. But interest rates, hey, that was pretty fun. We did rate, effect, and nominal effect. We talked about savings plans where you're depositing amounts different than interest is being earned, we saw the money tree, and now we saw the credit card example. All right, in our next video, we'll see loan analysis, where we get to put it all together and analyze different types of loan. See you there.